In this video, we're going to go over the power theorems, particularly 3 of them. Now, the first one we're going to talk about is the chord power theorem. And you need to use it whenever you have 2 chords intersecting each other. So let's say this is A, B, C, and D. You need to know that the product of the chord segments are equal to each other. So A times B is equal to C times D. So let me give you an example. Let's say this is A, B, C, D, and E. So let's say that AE is 8 and ED is 12. And let's say CE is 16 and BE is X. What is the value of X? Well, we know that A times B is equal to C times D. So this would be like A, this would be B. So 8 times 12 is equal to 16 times X. So it's the product of the segments of one chord that's equal to the product of the segments of the other chord. Now 8 times 12, that's 96. So 96 is equal to 16x. And now we need to divide both sides by 16. So 96 divided by 16 is 6. So BE is equal to 6. And that's a simple way in which you could use the chord power theorem to solve for a missing segment or something. Let's try another example. Let's say this is A, B, C, D, and E. So let's say if we're given that CE is 64 and CB is 82 and AD is 72. So go ahead and calculate AE. So feel free to pause the video if you want to try it. So we have CE, that's 64. We don't know EB, but we do have CB. CB is the sum of CE and EB. Now CB is 82, CE is 64. So EB is going to be 82 minus 64, which is 18. Now we know that AD is 72. And we don't have DE or AE. So if AE is X, what's DE? We know that AD is the sum of AE and DE. So if AD is 72 and AE is X, DE, if we move this to the other side, has to be 72 minus X. So we can write that there. Now we know that A times B is equal to C times D. So this would be A, this would be B. So we could say 64 times 18 is equal to C times D. So that's going to be equal to 72 minus X times X. Now 64 times 18, that is 1152. And here we have to distribute X. So 72 times X, and then negative X times X. Now let's take everything from the right side and move it to the left. And let's write it in quadratic form. So it's going to be positive X squared minus 72X plus 1152. And so that's equal to 0. Now we need to find 2 numbers that multiply to positive 1152 but add to negative 72x. So what are those 2 numbers? So if we divide 1152 by 2, that would be 576. If we divide it by 4, it would be 288. If we divide it by 6, 192. If we divide it by, let's say, 8, 144. If we divide it by 12, 96. If we divide it by 16, that's 72. If we divide it by 24, that's 48. Notice that these two numbers, they add up to 72. So if we make them negative, they will add up to negative 72, but still multiply to positive 1152. So therefore, to factor this expression, it's going to be x minus 24 and x minus 48. Now we can set both factors equal to 0. So x is equal to 24 and 48. And x is equal to AE. So we have two possible answers for AE. AE can be 24 or it could be 48. Now the other segment, DE, is 72 minus x. 72 minus 24 is 48, and 72 minus 48 is 24. So either way, one segment is going to be 24 and the other is going to be 48. So these are the possible answers. And so that's it for this problem. Now the second power theorem that we need to talk about is the tangent secant power theorem. So we're going to draw a tangent segment which touches the circle at one point, and a secant segment which touches it at 2 points. So let's say this is A, B, C, and D, and they have a common endpoint B. So this is the tangent segment, and this part here is the secant segment. CB is the external part of the secant segment. So t squared is equal to E times S. That's the formula that you need to know for this type of problem. So it turns out that the tangent segment is the geometric mean of the external part of the secant segment times the entire length of the secant segment. Now let's work on an example problem. So we're going to use the same letters. Let's call this A, B, C, and D. And in this problem, let's say that CB is equal to 24 and DC is equal to 8. What is the length of AB? So let's calculate the length of the tangent part. CB is 24, DC is 8, and our goal is to calculate T. So the external part is 24, and S is the entire secant, so that's 8 plus 24. So S is 32, E is 24. Now let's calculate T. So T is going to be the square root of E times S. So it's the square root of 32 times 24. Now 32, we can break that into 16 and 2. 24, we could say that's 8 times 3. And 2 times 8 is 16. So we have the square root of 16 times the square root of 16 times the square root of 3. The square root of 16 is 4. And since we have two of them, there's going to be 2 4s. And 4 times 4 is 16. So the tangent part is 16 square root 3. So the decimal answer of that is 27.71. And so that's the length of the tangent segment. Go ahead and try this problem. So this is A, B, C, and D. And in this problem, we're going to say that AB is 12 and BC is 9. So what is the length of segment CD? Go ahead and try that. So this is 12, this is 9. So we know that tangent squared is equal to the external part times the secant. So the tangent part is 12. The external part is 9. That's the external part of the secant. And the secant itself, what is S? Now let's call CD X. So the secant segment is going to be 9 plus X. So T squared, or 12 squared, is going to equal E times S, which is 9 plus X. So now let's calculate X. 12 squared is 144. And here we need to distribute the 9. So 9 times 9 is 81, and then 9 times X is 9X. So 144 minus 81 is 63. And 63 divided by 9 is 7. So CD is 7 units long. And so that's the answer for this problem. So let's call this A, B, C, and D. And in this problem, we're going to say that AB is 10, CD is 15, and so what is the length of segment BC? So AB is 10, CD is 15, and our goal is to calculate BC. So T squared is equal to E times S. So the tangent part is AB. The external part is BC. And the secant is from BD. So the external part is X. So this is going to be 10 squared is equal to X. And the secant part is going to be X plus 15. And so this is the formula that we now have. 10 squared is 100. X times X is X squared. And X times 15 is 15X. So let's take this and move it to that side. So we have X squared plus 15X minus 100, and that's equal to 0. So now we need to factor this expression. What two numbers multiply to negative 100 but add to positive 15? What would you say? Well, we know that 20 times 5 is 100. And so it needs to be positive 20 and negative 5. This will add up to positive 15. So to factor it, it's going to be X plus 20 and X minus 5. So if we set each factor equal to 0, the two values for X will be negative 20 and positive 5. If X is negative 20, that means that BC is a negative value, and that's not possible. So we have to eliminate that answer. Therefore, X is 5. And so BC is equal to 5. Now the last power theorem that we need to go over is the secant power theorem. So let's call this point A, B, C, D, and E. So this is the external part of secant number 1. And this is the second external part of secant number 2. Now secant 1 extends from point A to point C, and secant 2 is from E to C. And the formula that you need is this equation. E1S1 is equal to E2S2. So now let me give you an example problem. So let's say that ED is equal to 20 and DC is 10 and BC is 15. What is the length of segment AB? Go ahead and try this. So ED is 20, DC is 10, and BC is 15. So what's AB? So we have E1. E1 is 15, and we have E2, that's 10. Now S2, which is from E to C, that's going to be the sum of 10 and 20. So S2 is 30. Now S1, which extends from point A to point C, that's going to be x plus 15. So now we could use the formula E1 S1 is equal to E2 S2. So E1 is 15, S1 is x plus 15. E2 is 10, S2 is 30. So 10 times 30 is 300. Next, let's divide both sides by 15. (300) divided by 15 is 20. So x plus 15 is equal to 20. Now let's subtract both sides by 15. So 20 minus 15 is 5. So therefore AB is equal to 5. And that's it. So once again, we're going to say that this is A, B, C, D, and E. Now, in this problem, AC is equal to 24. And AB, that's equal to 20. And we're going to say that ED is equal to 4. So what's EC? All right, let's mark what we have. So ED is 4, and AB is 20. Now AC is 24, which means that BC has to be 4. And we don't know what DC is, so let's call that X. So E1 times S1 is equal to E2 times S2. E1 is segment BC, which is 4. And S1 is going to be the entire secant, that's AC. So that's going to be 20 plus 4, or 24. E2 is the external part of the secant, so that's X. And S2 is basically ED plus DC, so it's going to be 4 plus X. So now let's calculate X. So 24 times 4, that's 96. And then X times 4 is 4X. X times X is X squared. So let's move that to the other side. So 0 is equal to X squared plus 4X minus 96. Now, what two numbers multiply to negative 96 but add to 4? Well, for one thing, 96 is divisible by 4. And so this is going to be negative 24. It's also divisible by 8. And so this is going to be negative 12. Now, these two numbers add up to negative 4, so we got to change the sign. So negative 8 times 12 is negative 96, but negative 8 plus 12 is 4. So we could factor and say x minus 8 and x plus 12. So we have two possible values for x. X can equal 8 or negative 12. Now we can't use this because DC will be negative, and that's not going to work. So x is equal to 8. So if x is 8, we can now find segment EC. Segment EC is the sum of ED and DC. Now ED is 4, DC is 8, so EC is 12. This is the answer we're looking for. Let's work on one more problem. So let's say this is A, B, C, D, E, and F. And so in this problem, you're given that AF is equal to 9, EF is equal to 3, BC is equal to 12, DC is 18. So what is the measure of DF? Calculate the length of that segment. So AF is 9. let me put this in blue. EF is 3, BC is 12, DC is 18. So our goal is to calculate DF. Now looking at this problem, it might seem complicated, but it helps if you break it into its components. The first problem is a tangent secant problem. And so the letters that correspond to this are A, B, C, and D. So we see that DC is 18, BC is 12. So we need to calculate AB. The second part of the problem is a chord problem. And it looks like this. And the letters are A, D, B, E, and F. So we have that AF is 9, EF is 3, and FD is what we're looking for, that's X. But we need to calculate FB before we can work on that problem. So therefore, let's focus on this one. So we know that T squared is equal to E times S. The tangent part is 18. So this is 18 squared. The external part is 12. So we can calculate the secant part. So 18 squared, that's 324. And if we divide that by 12, S is 27. Now the secant part extends from A to C. And so that's 27. So therefore AB is going to be 27 minus 12, which is 15. So AB is 15. Now we could take that information and move along to this problem. So if AB is 15 and AF is 9, that means that BF has to be 15 minus 9, which means that it's 6. So now we can calculate FD. So we know that AB is equal to CD. So this is A, this is B. That's 9 times 6. And that's equal to C times D. X times 3. 9 times 6 is 54. And 54 divided by 3 is 18. And so this is the answer. That's segment DF.